Hey guys, how you doing? We're gonna pick up with lesson 5, talking about the mean absolute deviation. This lesson starts on page 21 in your binders. So open up to page 21. Take a minute and copy down the I can statements, which are I can calculate the mean absolute deviation, also called the MAD, for a data set. I can explain what the mean absolute deviation represents for a distribution. All right, let's take a look at the first warm-up question. It says, the distribution below shows the number of electoral votes for the president of the 50 states. What is the most appropriate measure of center for this distribution? Taking what we know about distributions, particularly when there's numbers that are far away from the rest of the data, numbers that are called outliers. This number right over here we could call an outlier because it's far away from the rest of the data. Notice there's a gap here. The data is really clustered right around here. This is the cluster of the data. So we probably wouldn't want to use the mean because the mean would be very affected by this outlier. When you add an outlier into a data set, it makes a huge difference on the mean. The problem with the mode is actually the smallest piece of data here. The mode is the one that most repeats. So the mode wouldn't actually be very good. So we would actually want to go with the median for this distribution, because the median would find the exact middle, and we know the median is the least affected by outliers. Let's look at the second warm-up question. It says, answer the following questions about absolute value. What is absolute value? Well, if you remember from the fall, we said the absolute value is the distance from 0. So the absolute value of -3 is going to be 3, because 3 is 3 units away from 0. 2.5, a lot of students think that these are opposites. These are not opposites. Opposites mean we change the sign. The absolute value is just asking how far the number 2.5 is from 0. The number 2.5 is 2.5 units away from 0. What we're talking about here is the number that's always positive. Okay, let's go ahead and take some our vocabulary down. The words you're going to want to know for this data set is, if you recall, we talked about the mean being also called the fair share. The fair share is just the idea that if we split the data up equally, like we did with the blocks in the mean video, we're talking about everyone having the same amount. You're going to hear this word a lot too, distribution. A distribution is a collection of values in a data set. The third vocabulary word we want to know is this idea of absolute deviation. And all we're doing is talking about the distance away from the mean. Let's take a minute and look at the two dot plots below. Both distributions are symmetric and have a mean of 10. If you recall this idea of something being symmetric, if you draw a line down the middle, they're exactly the same if you fold across that line. So this idea of symmetry would happen right here. We could see that if we folded this data over, the dots would land on each other. Same thing with this data right here. If we folded that over on that middle line, they would be symmetric because they would exactly land on top of each other. But what do you notice is different about these two distributions? You're right, this one is clustered, meaning it's all very close together. And this one has some big gaps here. Not gas, gaps. And so we would say this data has a large spread, or it's very spread out. In other words, if you could hug the data, which data would be easier to hug? The clustered data in distribution A, because the data is much closer together. Okay, if you turn your paper over to the other side, we can write actually a sentence about how they're different. And the distributions are different because the spread is far apart in the second distribution. And clustered in the first one, distribution A. We'll call that B. Okay, so that's kind of brings us to our main point for the day, is the mean absolute deviation of a data set is the average distance all the points are from the mean. So essentially today what we're going to do is we're going to take the mean of the mean. We're going to take the mean, we're going to measure, and then we're going to take the mean again. Which distribution would have a higher mean absolute deviation? In other words, if we look back at these distributions, is there one that looks like most of the points tend to be farther away from the mean? You're right. Distribution B would have a higher mean deviation because the values from the mean are more spread out.